Okay, lesson 5.6, log properties and laws. Today's lesson is going to be similar to what we did in the beginning of Unit 5 when we talked about the different rules with exponents. So when we, went through and we looked at when do you multiply exponents, when do you add exponents, right? So those type of properties exist for logs as well, okay? So it's just another type of function. It has its own rules. So we're going to go through some basic properties and then look at an example of applying those basic properties. I'll then give you the laws, all right, the logarithm laws, and on the left you'll see the exponent laws, just so you can kind of see a connection between the two, all right, because it really helps to think of logarithms as similar to exponents, all right, having a good basis of exponents does help you understand logs. And then in this part of the lesson, I'm actually going to skip it for this video, all right, because it won't necessarily help you solve the examples, but it really does help for just understanding where do these laws come from, okay? So if you are confused on like the proof on like where these are coming from, I have my lesson posted, and on the lesson there is a proof of it, okay? But for the video, and so that way we're not going super long here, I'm not going to go through it, all right? So we're just going to go, I'm going to expose you to the rules, teach you what the rules are, and then we're just going to go into applying them and seeing them in examples. So let's get right into it. The first basic property, we've seen this one before, right, when we were doing our graphing. When you take the logarithm of 1, so what you are asking yourself is you're saying b to the power of what gives me 1? Well, this will always be 0, okay? It does not matter what number that you're like is the base of your logarithm. Taking the log of 1 will always result in 0. And the y, okay? So I always like to ask why. Why is that the case? Well, if we just write the left side of that problem, so log b of 1, okay? Let's just set it to some unknown, like x, okay? Well, if I rewrite this as an exponent, so if I rewrite it as b to the x equaling 1, well, now let's rewrite the 1 as a base of b. So that's the same thing as me saying b to the 0. You can see that because I now have same basis, I can equate my exponent, and I get x of 0. So that means when you take the base of 1, log of 1, you're gonna get 0. You always get 0, okay? So log of 1 will always result in 0. Log b. So in this property number 2, what we're looking at is what happens when you take the logarithm and of some number, and that number is also the same as the base, okay? So for example, like if I said log 2 of 2, what would you get? And let's see if you can think of it for yourself, right? Like what I'm saying is b to the power of what gives you this? Well, that will always be 1, okay? And the y again, let's look at the y. Well, if I have some log base b, and I'm taking that of b, well, let's see what number we get. Okay, so x, it's an unknown again. Well, rewrite it as an exponent, so the base of my logarithm to the power of my exponent, that's going to be b, equal to what's in the inside of my argument. We'll equate the exponent, so this is technically b to the 1. So then x is 1. So you're saying that because these two are the exact same here, it will always result in 1. So that's your basic property number 2 of a logarithm, okay? Property number 3. When I take the log of some base, and that base also happens to be inside of the argument, but notice that you have this exponent here, okay? You have this exponent of x. Well, property number 3 says, hey, this is just equal to x. It's equal to just whatever you have up here. And again, why? Why is that the case? Well, let's look. So if I write my left side, log b to the x. Well, I have to set it to some unknown. I've already used the variable x, so I'm just going to use m or something. Okay, well, rewrite it as an exponent. So b to the power of m is equal to the inside of your logarithm, b to the x. Equate your exponents, and look, you get x. So that means that log b to the x, right? Like it's equal to some unknown, but that unknown is equal to whatever the exponent was, right? They're identical to each other. So this is equal to x. So you can see that when you take the log b, and inside you have this, where the base and the base of your exponent on the inside of the logarithm are the same, well, this is just going to be equal to the exponent, x. Okay, property number 4. I find property number 4 to be the one that most people get confused with. So property number 4 is also going to result in x, okay? So property number 4 is when you have an exponent, right, being put to the logarithm with the same base of that exponent, it's just equal to whatever is on the inside. So if you ever see the base and the base of the exponent being the same, so a logarithm, if you ever have a logarithm up in the exponent and the bases are the same, it's going to be equal to whatever is here. But again, the why, because I hate just learning a rule and like being like, hey, that's a rule, now take it and go with it. Like I always want to know why is that the case. So I'm going to look at specifically the new, like what's up in the exponent to prove this, okay, to show this to you. So log bx, let's write that. So if we think about what a logarithm is telling us, it's saying b to the power of what is going to give you that x, okay? Like it's b to the power of what is going to give you this x right here. So it's equal to some unknown y, all right? So that if I just rewrite this as an exponent, that is b to the y is the same thing as x, all right? So now we know that log b, like I just showed you, log b x is the same as y. So let me rewrite now this entire exponent here. So b log b x equals. Okay, well, I'm going to take this, what a logarithm tells me. A logarithm of some base of x is going to equal y. Well, that's right here, right there. So I'm going to rewrite that as b to the power of, I'm going to take this expression and put it right here. So that's b to the y is equal. Okay, I don't know what it's equal to. Well, look at when you turn it into an exponent right here. When we just rearrange this logarithm, we said that b to the y is x. So right here, b to the y, well, that's this x. So this right here, this numerator is going to spit out some number. It's going to spit out some number y. It's not a numerator. The exponent is going to spit out some number y, right? Well, essentially that b to the y, like when you set it up, that b to the y is whatever is equal to whatever your exponent, whatever is on the inside of the argument, okay? So if you ever see the base, like some exponent, being put to the power of a log with the exact same base, just know, okay, so if this confuses you, don't worry, just know that you just put it equal to that, okay, whatever you see on the inside there. So let's apply those 4 basic properties. I'm asking you to solve log base 300 of 1. So you're taking the logarithm of 1, right? That's what's inside the bracket here. Well, what number would 300 have to go to the power of to give you 1? Well, that's like using our property number 1, okay? So you're going to get 0. So this is property number 1. Log 30, base 30 of 30 to the 4. Well, this is going to be equal to 4. How did I know that? We'll go back to looking at property number 3. Being put to the power of log 31. Well, this is going to just be equal to 31. Because technically there is a 10 here on the logarithm. So I see the same base here and here. So that tells me from property number 4 that it's just equal to whatever's on the inside of that logarithm. Okay? D. 7 to the power of log 7. Well, you can see 7, so then this is just equal to 25. And once again, property number 4. Okay. So the product law of logarithms says that if I have some 2 numbers, some 2 unknowns, not even numbers, 2 whatever, multiplying, okay, m and n, whatever they are. It could be binomials, it could be singular numbers, it doesn't matter. What it is saying is that when you can see that there are 2 things being multiplied inside of a log, you can split it up where you do the log of the same base that was on the original, so still b, but you are taking them individually and adding them up, okay? So this is the product law. And the reason we're showing you the exponent on the side over here is think back to when you did exponents. When you were multiplying bases, all right, when it was a multiplication occurring, you ended up adding exponents. So when it is a multiplication occurring on the inside of a logarithm, you end up adding your 2, okay? That's one way to think about it and remember it. In exponents, when you did quotient or division, remember you ended up subtracting, okay? And if you think about product and quotient, right, like being division and multiplication being inverse operations, one being adding and one being subtracting, well, similar to logs. When they were multiplying, they were adding. And now when I have 2 things being divided, right, this is division technically, well, then you're going to subtract, okay? So you have a product law, you have a quotient law, just like we had in exponents. And then the last one is the power law of a logarithm. And what this says is that when you take the log b of something in the brackets, okay, and that has an exponent, you can just carry that exponent down in front and it becomes that, whatever that exponent was, multiplying what was in there before. Just you don't notice you don't have an exponent here anymore, okay? So that now is an exponent of 1. And it's honestly this property right here that allows us to solve like unknowns in the exponents, all right, when they're not, you can't do that whole changing of base. So let's go through some examples of using those rules, all right, those laws. Okay. And just like in previous lessons, at any point, just pause the video and try out these for yourself, and then just play again and see if you get the correct answer, okay? So in the first one here, I'm asking you to evaluate. So like I want a final answer. Like tell me, like if you were to put on your calculator log 8 of the 4 here plus log 8 16, what do you get? But we're going to use our laws to simplify. So this right here, this is our product law. And how do I know? Well, look, this is base B, same base, okay? So it's like me saying log B of M plus log B of N. So if I have this being my M and this being my N, right? The law says, well, rewrite it as the same base B, but just multiply the two. So this can be rewritten as log 8 of 4 times 16. So log 8, 4 times 16, well, that's 64. So log 8 of 64. So ask yourself, 8 to the what gives you 64? Well, that would be 2. Okay, so log base 8 of 64 is 2. Let's try it again here. Log 3 base 3 of 405 minus log base 3 of 5. Well, this is my quotient. And how do I know? Well, again, I can see that I have same base, B and B. So I can see that I have the same base, so, and they're separated by subtraction here. So that says I can apply my quotient law. And the quotient law is where I just take the same base and I take whatever my first number is I see, so in that case it'd be 405, and I divide it by the second number. So that would be 5 in this case. So that would be log 3 of 405 over 5. So how many times does 5 go into 405? Well, 5 goes into 48 times, and then 1 time into the 5, so that means that reduces to 81. So then 3 to the what gives you 81? 4. C. Log base 2 of this square root here. Not square root, cube root. And inside that cube root is 8 to the 5. So first step is get rid of that root. Okay, that looks confusing. So what I'm going to do is I'm going to rewrite it like this. 8, well, 8 is being put to the power of 5, but because I'm taking the cube root, that means there is technically a denominator of 3. So that is like this whole root is me saying 8 to the 5 over 3. Well, now I'm going to be using my power law. Okay? And the power law says, well, any logarithm, any logarithm where you have a number put to like an exponent, you can carry that exponent down in front. So then I can rewrite it as 5 over 3. So now the exponent is multiplying my logarithm. And now I have 5, 3 multiplying. Well, what does this evaluate to? What is log to base 2 of 8? So you always got to ask yourself when you're evaluating a log, you're looking at the base and you're saying, okay, what do I need to put that base to the power of to get what's on the inside? So that would simplify to 3, okay? So then you have 5/3 multiplying 3. So these 3's cancel. And you're just left with 5. If I go to D, I want to simplify this problem. So I'm looking at what law can I apply here, okay? So ask yourself, what base do I see a common base? Do I see positive? Do I see negatives? Like, what operation can I do? Well, I see that I have 10 here on both, okay? And it's separated by a positive. So I know that I can apply my product rule. But careful. The product rule, what it is not, okay? So the product rule is log m plus log n equaling log mn. But notice that this product rule does not have any coefficient in front, okay? It's not like I have a and b here. And in this problem right here, we have these coefficients. We have this 2 and we have this half. So you can't just directly apply this law right here because you have that a and that b. So we need to write it so that we have only a coefficient of 1 in front of both of these. So I need this to be a 1. So my first step actually is I'm going to apply my power law. That's the first thing I'm going to do. And I'm going to actually undo those 2 and those half that you see in front. So I'm going to put them back up top of the logarithm. So I will rewrite this as log 5 to the 2 plus log 16 to the half. Now I have coefficients of 1 here. And now I can apply my product rule. Okay, so careful. So because now they're coefficients of 1 and they're the same base and they're being added, I can rewrite this as log 5 squared multiplying 16 to the 1/2. Well, on the inside of that logarithm, 5 squared is 25. 16 to the power of 1/2. So essentially that's like me saying, hey, take the square root of 16. That's going to be 4. So 25 times 4, right? Because this is just multiplication here. So it's just 100. Remember, this has a base of 10. So 10 to the what gives me 100? Well, 2. So we applied our different logarithmic laws to be able to get a nice clean answer, okay? Because log 10 of 16 would not have given you a clean answer to start. So you can apply your rules and you end up getting a nice answer in the end. Question 2, simplify. Well, we have an addition, we have an addition, and we have a subtraction here. How can we approach this problem? Well, because all of these logarithms all have base 10, Oh, that one's also 10. You can expand your product law, okay? And your quotient law. So, like expansion of it means that if you have log b of m plus log b of n plus, let's put a third one in there, log b of, I don't know what's the next letter, m, n, o, that's a 0, so that will look weird. Let's do p. That is the same thing as me saying log b of m, n, p, okay? Like I can just do them all in multiplication on the inside. So all of this part right here, those first three terms, I can just treat as one big product law. So those first will be log, and then it would be multiplying x y squared times 3x. And then you still have the subtraction on the backside right here. Okay, we could have also added that in as well, but I will separate it just for now. Post practice, you can do it all in one line. And now you can think of this next step as a quotient law, where you have, again, same base, they're still the same base, right? And you have the first one, like think of all of this now as just m, the first one being just one big M, right? So you would take everything that you see in the first argument there, and you would just write it as a numerator. So that is x times y squared times 3x, all being divided by y. And now let's clean up on the inside. So on the inside, I have a y on the bottom, I have 2 up top, and then those two x's will multiply and add. So I will get 3x squared on my numerator, and y, actually the y on the bottom goes with just 3x squared y. B. Okay, so again, might have to take this in a couple steps, all right, but you can see that we have combination of product and quotient because they're all the same base here. So now let's try and do it all in one line, all right? Let's first get rid of those roots and write them as exponents. So the first term, I'm going to rewrite this as log 3. Well, this half right here, that is the same thing as x to the 1/2 to the 3. I'm just going to rewrite my second term. And then my last term is just going to be x to the 1/2. Okay, so this right here, let's clean that up. So that first term is log 3, x to the, well, multiply exponents, so that's 3/2, plus log 3x squared minus log x 1/2. Oh, sorry, base 3. Okay, well, we have a product and we have a quotient, so you can think of like all in one line now. We are going to add, or multiply, sorry, the things that are adding. So these two right here are going to be x 3/2 multiplying x squared, because those two are the ones that are being added, so those were like m and n, divided by the thing that we see on the back side here, because that's a quotient. So it's x to the 1/2. So just work with your exponents now. So we have log base 3. Well, essentially we have up on top here, this is like me saying I have 3 1/2s on that x, and I have a singular half on the bottom. So if I take away one of those halves, I'm going to be left with 2/2. So I will have x 2 over 2, which is the same thing as x to the 1, multiplying x squared. All right, and then when that went away, that went to 1 technically. So this ends up just being log 3x cubed. And then we can bring that 3 down in front using our power law. So that would be written as 3 log 3x. If this confused you on doing it as one line, by all means, do it like we did in the first example where you did it in steps, okay? I'm just showing you in a lesson that you can do it all in one line, that way you have exposure to it, but if that confuses you, by all means, please keep doing it in separate lines, okay? I'd rather you do it in multiple lines and get the correct answer as opposed to trying to rush it and do it in one line. All right, last example. We have the same logs, selecting the log base, they're being subtracted. So I'm going to apply my quotient rule to this. So that says, think of all of this as being m and this being n. What it says is I'm going to take that m and I'm going to divide by that n. So I'm going to rewrite it as log 2x minus 2 all over x squared minus 1. Okay, you might be thinking that's it, but we're trying to simplify as much as we can, okay? The question from the very beginning said simplify. So you're trying to reduce as much clutter as there is, cancel things out. So let's see what we have on the inside here. Well, our numerator, I'm going to factor out a 2, and I'm going to get x minus 1. On the denominator, that's a difference of squares. So that becomes x plus 1, x minus 1. So I'm going to cancel now my 2x minus 1s. And I get log 2 over x plus 1. And that's your final answer, okay? Don't undo this. Like, don't separate this into the quotient because that's not simplified then. So that's the lesson. All right, I will see you in class.